In this video, we will learn that how we can get Excel-like output without running regression model with the help of data. We have two variables. The one is DV, and that is sales, and the other one is IV, that is advertisement. And we have four observation. First of all, we calculate alpha head as well as beta head by applying this formula. To get beta head, we need xy and summation x square. So first of all, we calculate xy. Then we calculate x square by taking its square. And then we will take its sum. So we need sum of I, sum of x, sum of xy, and sum of x square. Just copy. Now, in this formula, first we calculate numerator and then denominator. Here, numerator is n summation xy. Here we have n is 4, summation xy, that is 210, minus summation x 12 multiplied by summation y 56. And then we have denominator, that is n summation x square minus summation x whole square. Now, if we divide these two, we will get slope or beta hat, that is 7. Now, we will also here n is for number of parameters, that is alpha and beta 2, and k minus 1, it would be 1, and n minus k, that is 4, total number of observation minus total number of estimator, and then n minus 1 because we need in the Anova, because here we have degree of freedom and we will use in Anova all these uh, calculation. Now, after calculating alpha hat and beta hat, now we calculate y hat. Now, y hat is basically alpha hat plus beta hat x. Over here, alpha hat that we have calculated this one. But before calculating this, I'm sorry, this was basically your beta, and I will place here. And now I will calculate alpha hat, and alpha hat is basically this one, y bar minus beta x bar. So first we calculate y bar here. Y bar is calculated summation y divided by number of observation, and x hat, sorry, y bar is basically average, and x bar is average of x, and that is 12 divided by 4. Now we calculate this alpha hat with the help of this formula y bar minus beta x bar. Here y bar is 14 minus beta that we have calculated earlier, that was this one, multiplied by x bar, that is 3. So it is minus 7. And now we calculate y hat. Y hat is alpha hat plus beta hat. So here alpha hat is minus 7, and we will fix it plus beta hat. Again, we will fix it multiplied by each value of x. And now we calculate u hat. Now, how u hat is calculated? It is the difference between y actual and y estimated, means y minus y hat. Here we have y minus this is y hat, and it should be equal to 0. And it proves the statistical significance of error term, that it should be 0. Now we need now we need RSS, ESS, and TSS. And look at the formula. We should have y minus y hat square. That is this one, square of this one, and then y hat minus y bar square, and then y1. So we calculate it. Now here is y, We have already calculated this, and now just take its square, power 2. And now y hat minus y bar, here we have y hat minus this is y bar, and we will fix it. And then we calculate y minus y bar square, but before calculating this, we will take its square. This would give us y hat minus y bar square. And then just copy it to the next cell and replace the value of this y g3, because here we have 4 b3, so just put here b3 and check the formula. Yes, it is okay. Now copy it down. Now we have ESS, TSS, and RSS. Now look at the formula. Just take its square, power 2, and again copy it here, power 2. And then again copy it down so that we can get the correct result. Now our RSS is 18, our ESS is 294, and our TSS is 312. Now after that, we will calculate S, and S is calculated with the help of this formula by taking its under root. Now in numerator, we have RSS divided by n minus k. We had already calculated this one, and we will take its power 0.5. So here we have S. Now to get the standard error of alpha and standard of beta, we use this one. We had already calculated S. Now we need this second part. And again, for standard of beta, we also need this second part. So we calculate part B. This is summation x square, and we will have to take it under root as well. So summation x square, here we have this one 42 divided by 4 multiplied by summation x square. Again, we have this 42 minus summation x whole square, that is 12 part 2. And we will take its under root as well, because in the formula we have under root term 0.5. Now after calculating this, we now calculate our next term, that is second part of standard of beta, that is 1 by summation x square minus nx square. Again here 1 divided by summation x square, that is 42, multiply minus n, that is 4, and multiplied by x bar square. Here we have x bar power 2, and we will take again its under root by putting power 0.5. So we have 0.4082. Now to get standard error of alpha, S is multiplied by this second part, and again for standard of beta, this S is multiplied by this second part. So this is our S, and it should be fixed because it is repeating in both formula, multiplied by standard error of alpha, and then just copy it down. We will get it standard error of our beta. Now we will complete this table because if we run this simple regression model while using Excel data analysis option in data, we have three parts. The first one is regression statistic, then Anova, and then significance of these intercept. So first of all, we calculate multiple R. Now multiple R is calculated. It is the basically correlation between y and y hat, or we can use this formula if we want to get it manually. So y hat, y minus y hat. So this is your y, comma, then y hat, this one. Again, oral function, y, comma, y hat. So 0.97073, it is correlation coefficient. Then to get R square, we need all these ESS, RSS, and TSS. Here, the first one is we will complete this Anova table. This is our K minus 1. I have written in sequence. Then copy it down. The next is N minus K, and the last one is N minus 1. Now, here this is basically ESS. We have already calculated this one. This is our ESS. Then RSS, that is 18. And then TSS, we can sum it, or we have this value 312. Now, then we have mean sum of square, means we have this ESS average, then RSS average, and TSS average. So we divide these square deviation by their respective number of observation or degree of freedom. So we will get these average deviations. As these are deviations, square deviations, and it look like variances, so that is called analysis of variances. Now F is basically ratio of this RSS and TSS, sorry, ESS and RSS. Now to get R square, here we have two formulas for R square, ESS by TSS, R1 minus RSS by TSS. So we can get ESS, this one, divided by TSS. Or we can get it 1 minus RSS by TSS. Here is RSS divided by TSS. So the same answer. Now adjusted R square, again we have two formulas for adjusted R square. One is n minus 1 divided by n minus k multiply 1 minus R square, and this term is subtracted from 1. So it is basically 1 minus, then we have this n minus t minus 1, means this one. Then n minus k, this one, divided by 2. And that is multiplied by 1 minus R square. So this is our R square. Or we can calculate this R square, just move here, by using the second formula, this one, adjusted R square, can be equal to 1 minus average RSS divided by average TSS. So 1 minus, here is average RSS, this one, divided by, sorry, this one, average TSS. You can see that we have the same answer. Then standard error, we have already calculated this standard error, and it is located here. The number of observations are 4. Now we have completed its first part, that is regression statistic, and we have also calculated its second part, that is Anova, only the significance of F, and that can be calculated with the help of Excel function, and that is F dist right tail, and first this value, comma, first degree of freedom 1, and then second degree of freedom 2. And even now it means that overall model is significant. Or we can get its critical value by using F inverse right tail. Here we have the probability, let's say 0.05, and divided by first degree of freedom 1 and second degree of freedom 2. So as F calculated is greater than this critical value, it means that overall model is significant. Now the last part of this regression output, first one is intercept, and we have calculated this one. And the second part, and second coefficient, that is slope, and then standard error. We have this standard error, and just copy it down. because it is written in sequence. Then p statistic, just we divide the coefficient by standard error, we can get this t statistic. And the p value here we can use equal to, here is the formula for p value, this one, t dist, t dot dist, and then tooted. And then here the t statistic, we will take its absolute value. Absolute, this one. And then comma, we have degree of 2 degree of freedom. So here 0.21, and for second coefficient, we have 0.022. And to get the lower limit as well as upper limit, we use this formula, A intercept minus critical value and then standard error. We have already this A intercept as well as standard error of error. And for second coefficient, we have a B intercept. Here we will use basically, here we B and B. Now, it is basically here we have B. I'm just correcting it. And next it is also here B as well. Just correct it so that you have the correct formula. Now it means that we need critical value. Here I'm writing the critical value of T. So we can use here for critical value T inverse function, T inverse, and write it, and the 0.05 and the degree of freedom is 2. So critical value is 4.3. Now for lower part, here A intercept, this one, minus then critical value, and then multiplied by standard error of alpha, this one. So it is lower limit, and just copy it to the next and just change here again intercept, and then plus this critical value and multiplied by again this standard error. We can fix it as well anyhow. And now just copy it down. So we have lower limit for both A and for beta. Now, while running the regression, you will get exactly the same output that we basically are getting by applying different formulas and with the help of manual calculation. Now, go to data analysis, then select regression, and select DV with label, and then IV with label, and then label and confidence level, and then let's say output range. We want to display this output, let's say here, and just OK. Here you just compare that we have the same output as we have done it manually. In the next video, I will explain, I will repeat all these calculations with the help of matrices. Thank you very much for watching this.